Awesome. Hey everyone, welcome to another Operators Data Science Community Meetup. Today we have Surya from the data science team, and he's going to go over various data obfuscation techniques that are being used for obfuscating this meetup's attendees' data. And over to you, Surya.
Thank you, Akanksha. Let me start by sharing the screen. All right. So you can all see my screen, right?
Yes.
All right. All right. So let's start. Good morning, everyone. This is Surya Prakash Pathak, and I'm a data scientist in Open Services team. Today, wanted to talk about data obfuscation techniques, basically cryptographic techniques, which are used in basically for this data science meetup attendees as well. But in addition to that, I'm also going to talk about different techniques that were being used in modern computer society. Yeah, let's give you an introductions to cryptography, types of cryptography, and then I'm going to talk about the main topic for this talk, which is the cryptographic hash functions, and followed by the demo, which shows different hash functions and how it is used and why it is used, and so on and so forth. Yeah, let's move forward. So cryptography. So as Wikipedia says, cryptography is basically the practice and the study of techniques for secure communication in the presence of adversarial behavior. It is a science of providing security and protection of informations. It is highly useful for data scientists to manage their data, to obfuscate their data. It is also used for developers. It is also highly used for software engineers in order to maintain the security in the computational system. It also has a huge applications in cybersecurity as well. So cryptography, as the word says, cryptography means secret writing. It's an art or it's an idea of obfuscating a word or phrase or sentence which you want it to be secret and which you want it to be readable by a particular person only. So let's just move down the history lane to to understand one of the earliest known cryptographic technique developed by Caesar. This is called Caesar's cipher, where Julius Caesar used it. It is the idea of the time at 100 BC, where he used this cryptographic technique where he shifted the letter by certain shift n, and I think he used the shift of 3. So basically A is replaced by D, B will be replaced by E. So using this cryptographic techniques, he used to send it in the army so that his enemies does not know what his cryptographic word means. So now with the development of this modern science and technologies, these kind of cryptography can be deciphered within microseconds. So basically, what is the main purpose of cryptography? The main purpose is authentication. It should authenticate one's identity. Also, privacy, ensuring that no one can read the message except the intended receiver. Integrity, assuring that whatever you cryptograph or whatever you encrypt, the message should not be altered in any way from the original. And it should be non-repudiation, means the mechanism to prove that the sender really sent this message. So on and whole, it is an authenticating policy or authenticating behavior of this technique. There are some types of cryptographic algorithms like secret key cryptography, which is basically a symmetric cryptography, where you have a text or a phrase or a word, you put the key, you encrypt with the key with the help of the key, and it is transformed into the ciphertext, which is then retransformed into the original text by using the same key. So this kind of cryptography is generally called symmetric cryptography. There's another called asymmetric cryptography, which uses both public and private keys. It uses two keys, one for encryption and the other for decryption. The third kind of cryptographic algorithm, which we are going to discuss in this talk today, is the hash function cryptography. It is the one-way cryptography, meaning you can encrypt a text using the hash function to some coded word. However, that coded word cannot be hashed back into the original text. It is also used in data obfuscation techniques by data scientists, which we see later. So what is hash function? A hash function is a function that can be used to map data to arbitrary sized to fixed size values. So say, for example, you have some word or you have some password which you want to make a hash of. So you can apply the hash function and transform that into data with n-bit array or n-bit data. So say, for example, you have a message or data block, you go to the hash function and it gets transformed into the hash values. Now, one of the important thing, or some of the important things that we need to understand about this properties of cryptographic hash are first is pre-image resistance. So say, for example, you have a word which you transformed it into the hash. Now, for the hash to be validated, for the hash function to validate that it's a good cryptographic hash, what should happen is the hash function should not retrieve to the original word. Say, for example, if you are hashing the word apple, the hashed version of that apple should not retrieve the word apple if you do any kind of inversion technique. The second pre-image resistance refers to the idea about if you have, like taking the same example, you have a word apple, you transform it into its own hash. But that hashed value should not retrieve back to any other word as well. So that is second pre-image resistance. The third is collision resistance, which you will hear a lot in the coming slides. So collision resistance is basically if I have two different words and they are mapping to the same hashed value, then that is violation of collision resistance. So that should not be there within the hash functions. So taking these three philosophies as the main crucial pinpoint for a good cryptographic hash function, let's see some of the highlighted hash functions that were used throughout the time, from the past couple of years. Okay, time for live demo. Let's go to the notebook now. All right, so you can find this notebook in the GitHub Operate First Data Science community, GitHub. I'm just going through different sets of this notebook to explain what each of them means. So as we know, we have these three different properties of cryptographic hashes. So one of the main hashing function or the hashlib module is our hashlib. It is a convenient hashing module that comes with Python interpreter. You just need to import it. So the first hashing functions, the earlier hashing functions was MD5. It is called Message Digest 5. MD5 is very popular hashing algorithm created long time ago. It has a 128 bit. It produces a 128 bit number that is 32 digits long. So here, as we can see in this example, we have the word hello, and we are transforming it to the MD5 hashed value. So when we do this, we have the hashed value appears over here. I want to show you one more thing. Okay, so if I go over here, so one thing which you need to understand is HELLO, all are lowercase. So if I make any one of the letter as uppercase, then the hashed value will be completely different for these cases. So this is MD5 algorithm, hashed algorithm, but later it turned out to be very ineffective because it does not hold up the collision resistance. This was the famous cryptographic paper was linked over here, which shows that we have two strings which are different and which produces the same MD5 hashed values. So here I'm putting the condition that if the two strings are equal, no. So the two strings are not equal. Even though they are not equal, their hashed values are equal. So this violates the collision resistance, or this does not holds up to collision resistance. Hence, MD5 is no more regarded as the secured algorithm. It is no longer in use. Another secure family of hash function is secure hash algorithm. It has SHA-1. Yes, Arthur?
Yeah, so does that paper that you mentioned earlier is
Yeah.
also publish the method that they used to break or to find these two sequences that basically produce the same hashing key?
I don't think so. They have
Okay.
published a method. Yeah,
Because
but
I was
we
curious
can
if they
have a look.
used some kind of like clever algorithm or they used some kind of like brute force just to compute this. Because if it's brute force, then yeah, I mean, it's still
Yeah.
hard to break MD5, right?
Yes, yes, but concerning the technology that we have now, like all these GPUs and a higher version of CPUs, it is possible through brute force as well. Like
Yeah.
it may take 1 day, 2 day, or 1 week, but the speed is tremendous as of now. So
Yeah.
it's we really
Okay.
need to be careful. Yeah.
All right. Thank you.
Yeah. Thank you. So this is an example of the two strings having the same hash values, which is bad for the MD5. Now another family is SHA-1, SHA-224, SHA-256, SHA-23, SHA-384, and SHA-512 are the families of secure hash algorithm, commonly known as SHA. Among them, SHA-256 and SHA-512 are considered to be the secured version of the family. There's another reported paper, or I think report paper, which shows that there is a hash collision for SHA-1 as well. So SHA-1 is no longer secure now, but SHA-256 and SHA-512 still hold on to its hash property. So here, as before, as we have seen in MD5, we transform the hash value of the word hello. As we see over here as well, we have the hashed value of version of this hello. And like before, if we change the uppercase of the letter, or if we change the small, like instead of H, if I write I, then completely changes the hash value. It does not mean that only the initial portion changes, but it completely changes the hash value. So the idea is like that. So what is the problem now? So we have one irreversible hash algorithm, SHA-256 or SHA-512, which can hash perfectly, which can hold on to its collision resistance value. So what is the problem now? The problem is with the speed now. How do the hacker hack into our system and retrieve these hash value? Now, one of the attack that the hacker does is the dictionary attack. So what he or she does is um, he has a collection of all the, let's say for example we are doing a password retrieving thing, and a hacker has a collection of all the commonly known passwords. As the data says over here, a dictionary containing over 1 billion unique words takes up to 15 gigabytes, so it's not much for a hacker. So if he or she has a dictionary of 1 billion password, commonly known password used, and its corresponding hashed value over here, he can retrieve the password that is in the system if the password is a common one. So I'm just showing a simple example over here. So let's say, for example, we have this data dictionary where we have some common password and its corresponding hash value. Now, this is with the hacker. Now, a hacker got the hold of the databases and he got the hash value of this. So in order to know what password this hash value is associated with, the hacker will loop over all the values in his dictionary. So when doing so, what happens is it stumble upon that hash value which has the corresponding word. So if the password is sunshine, which is pretty common password, then the hacker will know that it is sunshine. Now, how to get rid of this? How to get rid of this kind of dictionary attack? So one of the common use is the use of salt. What is salt? A salt is a random character string that is added to the beginning or end of the password or the original word. So say for example, just running this code. Say for example, we have the word sunshine previously, and now here we created the original, here we created the character list or the string, random string salt, which is a randomly generated number over here. It is added at the end of my string. So when it is added, the new hashed value is this one. So when the hacker again approaches my system with a dictionary, holding a dictionary, he or she will not be able to retrieve the password. So use of salt is very important in these cases. Now, what is the problem now? We have sorted the issue of having we have sorted the issue of retrieving from the dictionary attack as well. But with the advancement of CPUs and GPUs, it may take time. It may take one day for a hacker to retrieve the information. But with the use of salt, it might take them 1 week. But it will be retrievable because a hacker, when runs through different random number generation of salt, random number generation of salts along with the corresponding word, it will, however, the hacker will, however, be able to retrieve the word. So the issue that we are seeing so far is based on the speed of the algorithm that produces the hashing word. So far we try to, whenever we construct an algorithm in a normal case, we try to make it as fast as possible. But in cybersecurity or in these types of cases, we try to make an algorithm as slow as possible, so that when hacker loops over its dictionary or brute force, he or she will not be able to retrieve it within the time frame. So for that purpose, there are a couple of key derivation functions that are used, which uses this, which are comparatively slower than the SHA or MD5. So what is PBKDF2? PBKDF2 is a simple cryptographic key derivation functions, which is resistance to dictionary attack and rainbow table attacks, which is, and it is based on iteratively deriving HMAC many times with some padding. So basic important thing about this PBKDF2 is it takes on the value of password, it takes on the value of salt, it takes on iteration count, hash functions, derived key length. So moving on and looking at the how this PBKDF2 produces a hash value, we see that we have an iterations of 100,000. And we have some speed of producing this hash value. Now, if we increase this 100,000 by 10, it takes some time to retrieve that hash value. If we increase it more, then it takes more amount of time. So hence, the slower key derivation means high or logging time or slower description and high resistance to password cracking attacks. Faster key derivation means faster logging time or faster derivation and lower resistance to password cracking attacks. So this is one of the effective ways to implement the hash value by using the PBKDF2. So another kind of key derivation function is bycrypt, which is another cryptographic functions. It also uses similar concept of slowing down the algorithm technique of converting into the hash value. Now, as we can see over here, if we run this, it takes some time, but as we know, I think this gem salt uses some rounds, some parameters like rounds and bytes. So if we adjust some rounds, it has some speed. Now, if we adjust 10 to 15, it takes some time. Now, notice the difference between the PBKDF2 and the Bicrypt. For PBKDF2, I had to increase by 1,000 times the iteration speed by 1,000 times in order to come to a considerably slower speed. But for Bicrypt, I just need to move from 10 to 15, which is pretty sensitive in this case. Similarly, we have another hashing algorithm like script, which uses similar script, which uses similar syntax, and and in addition to the speed, it also depends upon the memory required. So the memory required for processing this algorithm depends on n, which is iteration count, r, which is block size, fx memory and CPU users, and p, which is parallelism factor. So as we run this, it does have some speed, and um, so it is considered considerably considerably strong than Bcrypt or PBKDF2. Now, one of the best algorithms so far is Argon 2, which is the modern ASIC resistance. I think ASIC means application specific integrated circuit, and GPU resistance secure key derivation functions. It has the password cracking resistance. Now, what it does, it has different variants as well. Now, what it does is it creates a password hash. In addition to that, it also creates a argent2 hash, which is random salt. That means it creates a password. It creates the hash value of the word, and it also creates the hash value of that password hasher, which means suppose this is the hash value of the word, and this is the hash value of the containing all the encryption keys. So we have here something like two-factor authentication techniques. And yeah, so Argent2 is, I think, it is the best hashing techniques that is used so far. And most of this algorithm is based on how slow its processing time is, so as to restrain the hacker into hacking into the system. But with the advent of huge machines, huge GPUs, CPUs, these things will always be broken down in the coming future. But the developments will keep going. Development to form a concrete algorithm which would be highly secure for password will keep going. Now, coming back to our Meetup attendees data, we have a sample of a sample of Meetup attendee data over here. We have first name, we have last name, we have their emails, we have the time joined and time exited informations. So even though so data analysis can be done, if we want to really make it obfuscated, we can just delete all these things and carry out the analysis, but that does not means anything. So we need to have the individual name informations as well. How to do that? We can do that by just obfuscating these names by doing the SHA-256 algorithm or SHA-512 algorithm. And once the obfuscation is done, we can for these emails, we can delete the domain information. We can just retrieve we can just take the order of the domain information, and we can delete the names in front. So this is how the obfuscation technique is carried. So we have the name of the attendee, which is hashed with SHA-256, which is then hashed with SHA-512, and the resulting hash value represents the name of that attendees. So this is how the hacking or the hashing process is done, or I hope you understood some parts of it. So going back to my slides, if I go over here, so some of the tips for secure password is we need to use a password generator. Normally when typing our own password, we generally stumble upon common words or phrases. However, using a password generator would be more effective for password creation. We should go over all our accounts and delete the ones we no longer use. We should use two-factor authentications whenever possible and regularly check each of our accounts. Some fun facts about password. These are the top 10 most common password list from the 2022 recent article in Cyber News. The link is over there. So if your password falls under this 10 list, it's time to change it now. And I hope you got something from this talk, and thank you very much. If you have any questions, let me know. Yeah. Thank you.
Thank you for your
Thank
presentation.
you. Thank you very
Very,
much.
very educative.
Thank you very much.
Thanks, Surya, for an amazing presentation. We learned a lot. And if anybody has any more questions for Surya, this would be the best time. All right, then. Thank you all for joining in, and thank you, Surya, again for your amazing presentation. Hoping to see you all again in 2 weeks. Thank you.